Hey everybody, I'm going to start this a little bit early today. Hope you are doing well, and let's just check that we got audio because I don't want to talk to no one. See if it actually will go. Cool, we're good. Hope you're doing well today. We're going to be at a kind of community inspired, thanks to Androby. He had mentioned it in a comment a while back about the LED module in Zephyr. So it took me a little bit longer today to fiddle with it, so that's why this is happening right now. But it is working. Let's see if I can pull it up here. This little guy. See, so this is Particle Xenon. It is kind of running through that example loop, and we'll go into that. But controlling LEDs on your board and using the Zephyr LED module to make that happen. It's just another alternative if you want to use maybe some more advanced flashing patterns or dimming or anything like that. So, but before we do, if you haven't already, please subscribe, hit that like button, and let me know what you think and what things that you'd like to see get covered here, because a lot of the suggestions, a lot of these live sessions come from your suggestions, your emails, your messages. So let's get going. If I can skip ahead here. Oh, skip ahead too far. So the LED module, you don't have to implement your own kind of, if you don't have anything super crazy in terms of LED animations, the PWM LED driver should do what you need. It allows you to blink and set brightness and in a more sane, happy API. There are some whoopsies that I ran into, and I'll just go over them quickly here in this presentation. I was getting some crazy DTS device tree errors during compilation, and I was like, I couldn't quite figure out what was going on, and that's why we're a little bit late. But it is working now, which is nice. And we'll go over all the important bits, and of course we'll be focusing mostly on the configuration, because that's probably the hardest part in Zephyr. Let me see. So what you need to do, this is important here, these are probably the most important pieces, is making sure that you have PWM enabled, and also config LED and config LED PWM. Config LED PWM uses the PWM driver, so without one you can't have the other. I'm also enabled the bootloader here, and log was just enabled by default, so you can kind of look at what's happening on the inside. Here's the fun stuff. So within your kind of root, I don't even, there probably is a Zephyr term for this, but within that root, that dash, and then that that curly cues between the two, that's where kind of these higher level definitions happen of per devices, and someone might correct me in the comments, which is fine with me, because I don't, there's probably some term, but so if we're going to be using the PWM driver, got to make sure that compatible is defined as PWM-LEDs, and then you can have as many PWM LED kind of definitions as you want, depending on your driver and how many channels you have. But this case I ended up using 3 channels, and you can see here that we're using the PWM peripheral, so that's pointing to the peripheral itself. That's defined a little bit later, and then and also the pin number that the physical LED is connected to. So those are 2 very important pieces that you're gonna have to know. So if you have multiple PWM peripherals, you want to make sure you're using the right one, and then also making sure you're using the right channel. So, and I just brought this out too. It's just like you can use these pin labels within your code, and this is what the sample that I've attached in the description below. I pushed it up to NRF9160 for other examples in drivers, and that link should just bring you right to the sample. You can take a look at this. I just modified it slightly for the Particle Xenon. You can see the definition, the overlay, and it's mostly working with the kind of the sample as is. So literally it was just like copy paste, and then I added that overlay, and also enabled the bootloader. Here are the other PWM, the LED definition. So we did the, let's see, that was red. So green and blue. You can see they're all on different channels. And if we run over to, I'll show you what I was doing here. So here's a schematic for this board. And I jumped in here and I looked around. I was like, all right, what are the pin numbers? Because I don't know them off the top of my head. So I just searched for red and I went down here and I just zoomed in a little bit. And fortunately, it's easy because it's on port 0, so literally 13, 14, and 15. So if you go back to the definition, you can see that I used 13, 14, and 15 RGB. Now here's the part that I didn't realize, and we'll go into like what happened, but you have to make sure that you have a PWM device defined, and also that you need to have a PWM device on your device. So this is like the generic PWM device that, as long as your hardware and the software, or the code around your device is supported, then you should be able to just call out that PWM driver. This is an NR52840. They did bring out that PWM driver, so you can use it. That's important. If you don't have a device that has a PWM driver, you might be out of luck using this driver. So it needs to be supported by the platform. It needs to be supported in hardware, and it needs to be supported in firmware on Zephyr itself. You can see here the channels that they should look particularly familiar. The numbers there, those are the pin numbers, 13, 14, 15. And by default, I think these LEDs are pulled or controlled. They're pulled through the NFET inside the device. So we just got to invert the channels. Otherwise, they're on by default. Just got to make sure that's fixed. So that's pretty much it for the overlay. So we defined the PWM LED device first, and then we just place this within the kind of the root of your overlay, and then defining each of the LEDs and making sure they're on a unique channel. So make sure if you have multiple LEDs and you want them to be individually controlled, they need to be on the separate channels. They can't be all on the same channel, or else they'll just be on all at the same time and it won't work. So important thing to know there. Also, very important, requires a PWM device. Make sure you get at least one PWM device defined and make sure that's actually supported in hardware and on Zephyr. And you'll see I got some cryptic errors because my PWM device was not defined on this particular board. So here's the error. Whenever you're compiling for Zephyr and you run into crazy __ device DTS or D, blah, 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 different number at the end, most likely it's not showing, it's not in your device definition or in an overlay. So it's either that, or sometimes you can get crazy device tree errors if your peripherals are not enabled in your configuration. So if you go back and if you did not define configure _ PWM, you might get some angry errors with a device tree, or like compilation errors just saying can't find PWM, what's going on. So for mine, it was just a bunch of stuff talking about this, and I was like, what is wrong here? And this is another kind of detractor for Zephyr, is that because a lot of things are used, they're macro heavy, they use a lot of macros, and macros are not easy to debug, and it's not very user friendly for people who don't spend a lot of time in Zephyr. So like, it even took me a while to figure out like what was wrong here. So I started, this is the thing that works for me for my debugging purposes, is comparing other working boards with mine and seeing what the differences are. So in this case, I went through and I just started searching for like the PWM definition, like, they're all there. They all look like the same thing as what's in other board definitions. And then I fiddled around some more, and then I was like, wait, I know it's calling out the, there was a couple errors before that. I was saying like the PWM initialization function was not being used. I was like, oh, PWM function. So I went and I looked in the particle xenon board definition for the PWM driver. Nowhere to be found. The definition, what I showed you guys earlier, and it wasn't in the overlay. So I was like, it just needs PWM 0. So I went through and I went back and I defined. Wait, I skipped too far. I defined that guy. So this is what happened. Is this was missing. So all I had to do is add it, and all was well, and it compiled and it started running. This is cool. Don't want to skip too far ahead. So that's the device configuration. Now you can use this in your own code. The code I provided down in the description box. You can just take a look at how it's being used. In this particular sample, it is using the older way of getting a device, using more of the runtime configuration rather than the compile time configuration with the macros. I know device DT get is the preferred way to do it because it should give you an error during compilation. So this is just how to get it, and that if you look at the top of the file, you can see what the LED_PWM dev name is being used as. So we get the device, and then we can actually use it as however we like. And they were also, in this particular sample, they also used a bunch of cool macros that basically pull out each of the labels from each of the LEDs, so they can be used as static strings, and then they can be referenced later on, and then just getting the number of LEDs as well. But this is all like Zephyr macro craziness that sometimes it's like, how does this just work? So hopefully as they proceed, things will make a little bit more sense. Maybe they get away from macros instead of adding more, because they are difficult to work with, even with other programming languages. Like when I'm programming in Rust, macros are like their own special thing. It's very difficult to debug a macro in like Rust, just because Rust is a newer language, but they're just sometimes really hairy. And you can see in this particular driver, if you search for PWM_LED, or it might be the other way around, .c, you scroll down at the bottom and it's like a bunch of chained macros that go, the first one, the second one, it's like, oh my gosh, all right, what's broken here? But as you kind of up your game in Zephyr, hopefully you kind of get an idea what the macros are doing. Here are some of the most important functions in this API. You're turning off LEDs, you're turning them on, you're setting the brightness. Brightness, that level is 0 to 100. It's set in percentage, and then the LED blink is just like a blink function, and that I believe those are set in milliseconds. For the first arguments, that's the driver itself, and then the second argument is the index of which LED. So as they're defined, they go 1, 0, 1, 2, 3. So you just set whatever index it is. In this case, we were using that array as the kind of index indicator, the array that we were getting the, I'll go back to it real quick. This particular array, the LED label array, so that's how we knew how many LEDs we had. You can take a look at the code, it's in the description if you want to see everything in context. But yeah, the important part is just like, here are some of the APIs that you can take advantage of, and you can see the sample. They're using the brightness to go kind of ramp down from 100% on to off. You can see setting the different blink ratios and things like that. So handy little functions, especially, I mean, I actually didn't really know this LED module existed up until Androby had mentioned it, and I was like, oh, well, I should definitely check it out. So I finally had a chance to check it out. So in review, Zephyr's LED module is just another way that you can kind of highlight or abstract away some of the craziness in Zephyr and make it kind of easier for you. But you have to make sure you have your board file and your overlay defined properly. enable both the PWM for this. In this case, enable both PWM driver and the LED driver and the LED PWM option, and make sure you're calling them, calling things appropriately and pulling things from your overlays. But the biggest thing is just getting that configuration right, because if you don't know what's wrong, it can be kind of tricky there. So there were some questions in the chat. Hey everybody, so Solulus had a question about basically it's sort of related to pins and things, but handling GPIO interrupts and then servicing an I2C device, and doing that in the interrupt context. And I've tried this before and it doesn't work. You'll actually get a fault or get an assert being like, hey, you can't do these things in an interrupt context. One thing that you can do, especially if it's real time, Cyrus, is create a high priority thread, or like a work thread, and set it as high as the application priority as possible. That way, at least you can service that peripheral as soon as possible, and that way it'll preempt any other threads that are going on in the background. There might be some real-time stuff that you might be able to do in an ISR, but beyond the high priority thread, that's the only thing I can think of off the top of my head. Because I know certain sensor applications and stuff, you gotta be right on it. You gotta be sensing those drivers. So sorry I didn't have an exact answer if there's a way to do it, but there are some workarounds that you can try. Hey Costas. Hello. Let's see, Christopher. I guess using inverted mode of one channel would be helpful if mixing LED strips like cold and warm white while dimming without requiring double power from your power supply. That's interesting. Like you basically doing a phase shift to some extent. I never really thought about that. That's a good idea. Yeah, what Christopher was saying is you can, if you don't really care about the off state of the device and you have some cool white LEDs and some of the opposite of the then you could run them 180 degrees off of each other, and then basically you're just using the same amount of power, which is cool. That's a good idea. And then let's see. Hey Franz, thanks for being here. Good to see you. But that is about it for today. Of course, if you have any suggestions, questions, I might stick around for a second. Just make sure there's no more questions. But I'm always here. Feel free to leave a message here. Send me a message. Send me an email. I like the community suggestions because sometimes I end up scratching my head. I'm like, how does this work? I'm not sure. But I really appreciate you all. Thank you so much for being here. And I'll see you next week.